Good day everybody. We are expected to find the eigenvalues of a 3 by 3 matrix. So we're given A is equal to 3, 1, 1, 2, 4, 2, 1, 1, 3. Foremost we will set up the characteristic equation. So that is of the form A negative lambda I is equal to 0. So this is actually a determinant. So this will be 3 negative lambda, 4 negative lambda, 3 negative lambda, 2, 1, 1, 2, 1, 1. And this is equal to 0. Now we will have to expand this. So set it up. 3 negative lambda will be the first element. Leave the row and the column. You got 4 negative lambda, 2, 1, 3 negative lambda. Place a negative sign. Place the element. Leave the row and the column. You have 2, 2, 1, 3 negative lambda, 2, 2, 1, 3 negative lambda. This is going to be positive 1. Leave the row and the column. You have 2, 4 negative lambda, 1, 1. And this is equated to 0. So you will have to get this system. So 3 negative lambda, you multiply it along this side. So it's going to be 4 negative lambda times 3 negative lambda. Along this side there is a negative sign. So 2 times 1 followed by negative 1 times 2 times of 3 negative lambda. You multiply it along this direction. While you move this direction, you take a negative sign. This is followed by 1 times 1 into 2 negative of 4 minus lambda, right, equal to 0. So this is 3 negative lambda of 4 3s are 12, 4 into lambda, negative 3 lambda, positive lambda squared, negative 2 lambda, negative 1 into 2 times 3 6, 2 lambda, negative 2, positive of 2, negative 4, positive lambda is equal to 0. Now this is going to be 3 negative lambda, 4 with 3, that's negative 7 lambda, a positive 12 and negative 2, that's 10. You have a lambda squared there. And negative 6 with negative 2 is 4 negative 2 lambda. Then positive of 2 negative 4 is negative 2 positive lambda is equal to 0. So this is going to be 3 multiplied with 10, that's 30. 3 multiplied with 7, that's 21 lambda. 3 multiplied with lambda squared, 3 lambda squared, and now lambda into 10 negative lambda, that's going to be negative 10 times the lambda, and positive, that's 7 lambda squared, and then this is going to be degree 3, lambda cubed, negative 4 positive 2 lambda, negative 2 positive lambda is equal to 0. So you have a negative lambda cubed. Now 7 added with 2 will be 10 lambda squared. So this is gone, this is gone, this is gone. Negative 21 with negative 10, negative 30, negative 31 with 4, that's negative 35, and negative 2 with negative 37. So this is gone, this is gone. So negative 37 with 30, that's going to be negative 7, right? So all these things are gone. And do we have anything else? So let's check for a lambda. So we have one lambda there. So we will have to do some checking in this case. So you take negative 21 and negative 10, that's negative 31. And you have a 2 lambda with 3 lambda, so you have to take away that. So this addition will give you negative 28. So negative 28 lambda. So that is for the lambda part. See, next you add negative 4 with 2, that's negative 6, you added with 30. That will give you positive 24 is equal to 0. Okay. So this is what you have got. Now what I'm going to do is I need to go to another page. So let me write the system. We now have negative lambda cubed positive 10 times lambda squared negative 28 lambda plus 24 is equal to 0. You multiply by negative 1. So this would give me lambda cubed negative 10 lambda squared, and then positive 28 lambda negative 24 is equal to 0. So this is what you've got. Now this is cubic in lambda. So what I'm going to do is I'm going to use synthetic division to reduce. So how do I do that? You draw a line like this, take the coefficients of the equation. So coefficient of lambda cubed is 1, lambda squared is negative 10, and lambda is 28, and the constant is negative 24. Now this is done by trial and error. Okay, so you will have to make a choice of the numbers. Now seeing 24, I'm going to select 2. Okay, now bring this 1 down. 2 times 1 is 2, negative 10 added with 2 will give you negative 8, 8 times 2 is negative 16, and this is going to give you 12, right, positive 12. So 12 multiplied with 2 will give me 24, 24 added with negative 24 will give me 0. So the quotient is going to be 1 degree less. So this is lambda squared negative 8 times lambda positive 12 is equal to 0. So from here already lambda is equal to 2 is an eigenvalue. So use quadratic formula. A is 1, B is negative 8, and C is 12. So lambda is equal to negative B plus or minus B squared negative 4 times AC divided by 2 times A. So this is going to give me 864 negative 4 times 8 times 8 is 48. 4 times 12 is 48. So from 64 you take 48, what is that, divided by 2 is going to be 8 plus or minus root of 16 divided by 2, which is 8. Root of 16 is 4, so you have 12 divided by 2, which is going to be 6, and 8 negative 4 divided by 2, which is 4 divided by 2, which is going to be 2. So 6 and 2 are the values. So lambda is equal to 6 and lambda is equal to 2. So you have 3 eigenvalues. Now having got the eigenvalues, our next step is to find the eigenvectors. Okay, so let's do that. Okay, we are going to find the eigenvector associated with lambda is equal to 2. Now we have this parent matrix which is 3, 1, 1, 2, 4, 2, 1, 1, 3. So we set up the system as A minus lambda times I times the vector is equal to 0. Now for each of these eigenvalues we will get a vector. So we got 3 eigenvalues. So lambda is equal to 2, lambda is equal to 2, and lambda is equal to 6. So if V1 is associated with lambda is equal to 2, V2 is associated with this lambda is equal to 2, we will have V3 associated with this lambda is equal to 6. So 3 vectors we will have to obtain. So having given you that information, let us move on. So for lambda is equal to 2, this is going to be the algorithm. So 3 negative 2 and 1 and 1, 2, 4 negative 2, 2, 1, 1, 3 negative 2. So this is what we have got. And V vector, I'm going to take it as x1, x2 and x3 is equal to, we are equating it to 0, 0, 0, 0. So the row with the column. So this is, let me resolve this. This is 3 minus 2 is 1. This is 1, this is 1, this is 2, this is 2, 2, 1, 1 and 1 multiplied with x1, x2 and x3 is equal to 0, 0, 0. So row with the column. So 1 into x1 plus x2 plus x3 is equal to 0. Row with the column 2 times x1 plus 2 times x2 plus 2 times x3 is equal to 0. Row with the column x1 plus x2 plus x3 is equal to 0. So you have system 1, system 2 and system 3. In this case you should not try to solve them. Okay, what you have to do is the concept called as parameterize the solution. So what does that mean? That means you take 3. You see, from 3 I can rewrite x3 as negative of x1 plus x2. So that means the vector form, okay, v vector that we are associating with, or I would say v1 associated with lambda is equal to 2, will be of the following form. What is that going to be? X, y, negative, or I would say x1, x2 and negative of x1 positive x2. So this is going to be the form, and adding all these things should give us 0, right? So if x1 is equal to 1 and x2 is equal to 0, so we have a vector. So what is the vector? So let me call that as say vector 1, which will be x1 is 1, x2 is 0. So this is going to be negative of x1 and x2. So that's going to be negative of 1 positive 0. So that is going to be a form of this vector. Now there is also another case where x1 is 0 and x2 is 1. So let me write that case also. So vector 2 is going to be x1 is 0 and x2 is going to be 1. So in this case it's going to be 0, 1 and negative of 0, positive 1. Okay, so what do you understand? There are 2 vectors associated. There are 2 vectors associated with lambda is equal to 2. Now these 2 vectors, say vector 1 and vector 2, they are linearly independent. They are what? Linearly independent. So that means we can use them as the basis to span the entire data space. So that would be the conclusion for this class. I have extracted the vectors for lambda is equal to 2. Your assignment is to get the vectors for lambda is equal to 6 and lambda is equal to 2. And you can post your solution in the comment box. Thank you everybody. Please like, share and subscribe.